Okay, so let's start with observing the decay of the uranium-211 atom, and we're gonna write a nuclear equation for it. So, the PO211 atom has 84 neutrons. So, if you make it into the helium atom, you can see that by adding this is how you get the helium. You see that the 211 subtracted from 84 equals a 2, and that the 211 subtracted from 207 equals 4, and that's how you get the helium atom. And that'd be question number 1. Now, for question number 2 is why during when a nuclear explosion, when an atom or a nuclear atom decays, there's a flash at the same time that an alpha particle is ejected from the nucleus, and it's why it happens. And it's because the nucleus is releasing energy. That's why you see the flash of light, and it does that to become more stable. That can be viewed because you'll see that the nucleus shakes and continues shaking until it releases a nucleus. Moving on to question number 3, which will be you'll see that when a nucleus decays, you'll see that the total energy doesn't change, but the potential energy decreases. Because again, it's releasing the nucleus. Now, moving on to the half-life of the uranium PO211 atom, and it's approximately 500 milliseconds, which is half a second. And first, we'll sketch what I believe the life will look like, which will start out like this. And I believe that would move on to look like this. Move on to this. And lastly, get even smaller. In reality, what it looked like is it started out this, and the pie chart moved on, and finally, and at last, this was at about 4 seconds in, I want to say, 4 or 5 seconds in, is what it looked like. And the reason I say that my prediction was off is because I didn't know where to start off the graph. I mean, if I'd say that I didn't know how fast it decayed too. That's why I thought my prediction was off. Now, if you start with 10 atoms of polonium, so we're dealing with the PO211 atom, and at 0.5 seconds later, only 5 will remain undecayed. Oh, I guess I should. At 0.5 seconds later, it's a half-life. Only 5 will remain undecayed. What if you start with 500 atoms? You can assume that 250 remain undecayed. And that would be question number 6, and that'd be the full first problem set of nuclear. Look at this, Nicolette. And next, we're going to observe the hydrogen-3 atom, which is the beginning of problem set number 2 for nuclear. And the hydrogen-3 atom, which is grade 1, moves on to H11, and you can see that by only this, because we're adding a helium atom, or 2. And that's why, because you take the 4 and the 3, you get the 1, and you take the 2 and the 1, and you get the 1. This is why you get the atom. Now, before the decay of the helium, or of the hydrogen 3 atom, and the helium-3 atom.